Hey guys, so welcome back to your next lesson of catalyst concepts. So in the previous class, we began the first chapter, the first topic in the chapter, that is current electricity. We tried to understand what exactly is this current and how it works, right? So we looked at the basic functioning of what is needed to make an electric charge or a current keep flowing through a circuit. We said there are two major components. One is the conductor that is used, and the other is the battery that is, or the power source that is available, right? So if we have two wires coming out connected to a battery and then connected then to a bulb in turn, assuming the battery is working fine and the conductors are actually conductors, then only then will the bulb glow, right? We also looked at the mechanism for this. It's quite simple. The electrons inside of a conductor are always in a very random state, okay, or let's call it a disordered state or unordered state, right? And once you put a certain charge to it or a power source to it, we say that they'll start, all the electrons start moving in a specific direction, right? So we showed it kind of like this. These electrons just going in the same direction, right? Now we call this the cross section of a conductor, right? Basically, like if you just cut it and you look through the side, this would be the cross section, kind of like a pipe, right? It's just like a very tiny conductor, so it's like a small thing, right? So in terms of language, let's say in terms of a definition, how could you define conductor electricity, right? If I have to define in general terms, I'll say nothing but electricity is ordered motion of electrons. Very simple. By ordered, I mean when they go in one direction, like all of them going in the same direction without deviations, right? That is what an ordered motion of electrons means. And that exactly is what electricity is, right? All the electrons moving in a specific direction. So this is how we can simply, in simple words, define electricity. But how do we define it according to like physics, like in terms that you can measure it? Okay, so we call them as quantitative terms because we can get like how much current, what current, and it's always going through the this thing. Like we've heard about when you see electrical lines, you'll say, oh, this much voltage is there, this much current is coming and all that, right? That how do we measure? That is one question that we're going to answer today. Okay, so if I have to define current in terms of how to measure it, I'll simply say that electricity is, okay, sorry for the spelling, electricity is nothing but the amount of charge moving through the cross section of a conductor in 1 second of time. Okay, I'll say amount of charge moving through cross section of conductor in 1 second of time. Okay, no, it's a slightly long sentence, but it actually means something very simple, right? First, let's strike off the part that you already know, that is cross section of conductor, right? So charge moving through cross section. Why is it moving through here and not through any other direction? It's simple because the conductor is connected through this end to a battery, right? So if this is this thing, the cross section is something like this, okay, like this part of the cable. If we cut it, we see that it's going this way through to the battery, right? So we'll say that any amount of charge moves through the cross section. That's why we're talking about cross section. That's not a big deal. Don't think too much about that. Okay, the major thing is 1 second time and amount of charge. Okay, 1 second time we know. So we measure how much in just 1 second, what change is happening. So that is just the time limit for that. What is this amount of charge? Okay, now if you remember, we said that electricity is nothing but movement of electrons, right? These electrons are charged particles, right? It's something that we've studied in when we studied about atoms, right? We say electrons have a negative charge, if you remember, right? Although it's a very small charge, it is charged. And if there are millions of these small charges, it becomes significantly big, right? Because in one conductor, there's like millions upon billions of atoms and electrons within them. So all of these negative charges combined is what is the total charge that we're talking about, which moves, right? Okay. So how do we measure this amount of charge and this time? Time so we can directly measure. Okay, so assume that Q is charge, okay? Okay, we'll take a capital alphabet Q for the charge that is going, okay? Just the charged particles moving, okay? And in a time T, we'll say that in T amount of time, Q amount of charge is moving through a conductor, okay? So if I have Q charge in T time, then I'll simply say that electricity, or I'll just call it current for now, shorter word. Current equals to amount of charge divided by time. Okay, if I divide it by time, it will tell me 1 second mein how much. Okay. Now, this is nothing but the formula for current. Okay. Now, what is the symbol for this current? It is nothing but capital alphabet I. Okay. So if I have to measure current, I will say I equals to Q divided by T. All right. Now, this is the formula for it. If we have Q, if we have T, we can simply find out what is I. But what exactly is the units for each, right? Unit is important for everything that we measure. Now, when we talk about charge, we say that charge is measured in coulombs. Okay. Coulomb is a unit that we have studied, I think, sometime before, maybe not this year, but it's something. And time is measured in seconds. Okay, we cannot measure in minutes. It has to be in seconds. You have to break it down to seconds if it's in minutes. So if I should do Coulomb divided by second, then I can find unit of current. So unit of current equals to Coulomb per second. Okay. This Coulomb per second is nothing but what we call as ampere. Okay, so ampere equals to Coulomb per second. I can simply say if 1 Coulomb of charge is moving through conductor at 1 second of time. Okay, in 1 second, if 1 Coulomb charge is moving, then I say 1 by 1 is nothing but 1 ampere. Okay. So ampere would be simply defined like this. 1 ampere is when 1 Coulomb of charge moves through the cross section of a conductor in 1 second of time. And that's actually a lot of current. Okay, 1 ampere is a very big unit of current. We generally don't use that much current in daily life. Okay. Now, so these coulombs can be measured based on how many electrons. Okay, since we said that electrons are the ones that are giving the charge, how many electrons does it take to make 1 Coulomb of charge? That's also a question that we can ask, right? Is it 1 electron, 2 electrons, 10 electrons, how many electrons? Okay, so one electron has a very small charge, which is 1.6 into 10 to the power minus 19 coulombs, which is very, 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 very small. By 10 power minus 19, we mean decimals before 1, right? So that is 0, 0, 0, 0, so many until 19 zeros will get. Okay, so how many electrons does it take to make 1 coulomb charge? Okay, it takes around 6.624 or 5 into 10 to the power of 18 electrons. Okay, that is basically into 10 power 18 means 18 spaces, right? You need to move this decimal point. So that will be 6.62500000000 16, 17, 18. Around these many electrons, if these many electrons move, then we say 1 coulomb of charge is moving. Okay, and that's not a few number of, that's a lot of electrons, right? It's a heavy number, right? So it's okay, don't worry so much about this part, right? Just understand that coulombs are measured by electrons, right? These many electrons, and when these many electrons move, we say 1 coulomb of charge is moving. And if that much charge is moving in 1 second, we say 1 ampere of current is being generated. Okay. This is the formula that we'll be using. I equals to Q by T. Just remember the units for all. I is amperes, Q is coulombs, and T is seconds, right? So I'll stop here for today. In the next class, we'll talk about how we can use this formula, and we can we'll also go ahead with numericals whenever it is needed. Okay. All right, then thank you so much. If you have any doubts, questions, comments, you can just put them in the comment down below, and I'll see you again in the next class. Thank you.